Welcome to our maths class. Today I want to wind up on investment appraisal techniques by looking at the remaining two methods or techniques that are used for investment appraisal. The two techniques are net present value and internal rate of return. So let's start with the net present value. The net present value compares how much cash an investor will get back from the investment and how much cash they had to pay for the investment. So we are looking at the cash outflows compared to the cash inflows so that we can get the net. With the net present value, all cash flows must be compared in net present terms. And in this technique, if the net present value is a positive figure, then we accept the project as being viable. If the net present value is a negative figure, we reject the project as being unprofitable. Let's look at the exercise. A company is evaluating a project that has the following cash flows. It will purchase a machine on January 1, 2011 for $50,000 and will receive net cash each year from the trading activities as follows. So we have about 4 years and those are the net cash flows. The company can borrow money at 10%, so that's the cost of capital, and is the project worthwhile? So let's see if the project is worthwhile. Let's see if the project is worthwhile. We just need to compare the cash outflows and the cash inflows. So we have the 50,000 as the purchase cost, so that's the cash outflow. We have 20,000, 10,000, 20,000, and 50,000 as the net cash inflows. The only thing we need to do here is to bring all figures into present value terms. So let's have a table to work with. Insert a table down here under your solution. So a table of 6 columns, 4 columns and 6 rows will do for this number of years. We have 4 years in particular. So what we have in the first column, that's the year. Then we have the net cash flow. Then we have the discounting factor. Then we have the PV. If you remember very well, in one of the videos, I looked at discounting method. Under discounting method, we were converting the future values into the present values. And how did we do that? We multiplied the future cash flows by the discounting factor to bring them into the present values. That's what we are doing here as well. To calculate the present value, multiply the future cash flow by the discounting factor. So let's see. Years, we have year 0, year 1, year 2, year 3, and year 4. There are 4 years. What is year 0? Year 0 represents now. Now is year 0. So what are we spending now? The company is spending $50,000 to purchase the equipment. $50,000 is an expense, so this is a cash outflow. Then that is followed by 20,000, 10,000, 20,000, 15,000 of the cash inflows. The last one is 15,000. Discounting factor. The discounting factor here at 10%. We are told the cost of capital is 10%. For the DF, discounting factor, you use the present value tables to get that. So if you refer to the table, of course for year 0, you always have a 1.00. But for year 1 from the table, you get 0.909. For year 2, you will get 0.826. For the third year, you will get 0.751. The fourth year, you will get 0.7 683. So multiplying the cash flow by the discounting factor, you should get 50,000 cash outflow. That is going to be compared with the cash inflow. So 20,000 multiplied by 0.909, you should get 18,180. 10,000 by that, you should get 8,260. 20 by 0.751, you should get 1520. The last one, 15,000 by 0.683, you should get 10,245. 10,245. So net that together by adding the positive cash flows, the cash inflows, then subtract the cash outflow. When you do that, you should have your net PV of 1705. 1705. That should be your net present value. So that's how we calculate the net present value for a project. And since this is positive, it means that the project is acceptable. So your answer, you will conclude that yes, the project is worthwhile. Yes, the project is worthwhile. Yes, the project is worthwhile. That should be your conclusion. Let me quickly look at the internal rate of return. The internal rate of return is the rate of return at which the NPV equals 0, and that's the formula on how we calculate the internal rate of return. So let's look at the exercise. A project costing 1,000 will return 180 in the following year. What will be the NPV at discount rate 10% and 20%? So you're calculating the NPV. So let's quickly get a table that can help us work out these 4 columns, of course, and 3 rows will do. So what's there here? Cash flow, discounting factor, TF, and PV. Discounting factor, let's start with a 10%. So discounting factor at 10%. So what we have there, year 0. The following year is year 1. So in year 0, we have a cost of 1,000. That's a cash outflow, $1,000. Put it in brackets. And in year 1, the return is going to be 1,180. 1,180. That's the cash inflow. That's the cash inflow. So the DF in year 0 is always 1.00. Then the DF at 10% for year 1 is going to be 0.909. So multiply the 2 figures, you have a cash outflow of 1,000. And what will be the cash inflow? So 1,180 multiplied by 0.909, that should give you 1073. 1073. So compare that. Your net present value, compare that, your net present value in PV will be equals to a positive 73. Positive 73. So at 10%, the investment is profitable. So what happens if we consider 20%? So what will be the result at 20%? So DF at 20% will be, for year 0 it's always 1, for year 1, so year 1 at 20% should give you 0.833. 0.833. Why am I getting these figures? From the present value table. Get those figures from the present value table. Those figures from the present value table. So if you multiply -1000 by 1, that's -1000, but 1180 multiplied by 0.833, you should get 983. So your NPV here is going to be a negative. So 1000 minus 983, 1000 minus 83 NPV will be equals to, you should get a -17. So at 20% the project is unprofitable. So then let's look at the internal rate of return. Internal rate of return is that rate that will give us NPV equals to 0. So at what point, at what rate will our NPV be equals to 0? So let's bring in the formula for internal rate of return and substitute. Now this is the thing, A% results in NPV of A. So A% gives us a positive NPV, B% gives us a negative NPV. So which rate is giving us a positive NPV? That's a 10%, giving us the positive NPV of 73. So A% will be 10%, capital letter A will be the NPV of 73. So let's factor those things in our formula. So what we have there, we have our 10% that gives us the NPV of positive 73, and that is going to be a positive 73 as well. What is, that's A, that's our 10%. So what's B? B is the rate that gives us a negative NPV, so B is going to be our 20%. And B is going to be a -17. So we have to put that in brackets, -17. So when you multiply there, a negative multiplied by a negative will result in a positive. So the denominator here is going to be 73 plus 17. Those are rules of mathematics. So let's see what we will have if we did that. So we have our 10% there. On top we have our 73. What is 73 plus 17? What is 73 plus 17? 73 plus 17, we have 90. So that's going to be 90. That's going to be 90. So this is going to be 20%. 20% minus 10%, that will be a 10%. So we have 10% put in brackets like that. So what is 73 divided by 90 multiplied by 10? 73 divided by 90 multiplied by 10. Let me just work out 73 divided by 90, then answer multiplied by 10, that will give you 8.11. So 8.11. So the internal rate of return will be 10% plus this will result in 8.11%. So put everything together, your internal rate of return is going to be 18.1%. Well, that's how we calculate the internal rate of return. So calculate the NPV at the two given rates and then find a rate that can give you the NPV of 0. So 18%, 18.1% will result in the NPV equals to 0. Thank you so much for watching. Look out for the next video.